So for this last video, I'm going to be showing you 3 special cases that come up that can be, it should be really the easiest types of problems to solve, and they are once you understand the concept. And just a quick reminder, when you're solving an equation, you're trying to find all of the real numbers that you can replace the variable with that would make the equation true. So for example, I'll just put another one up here. Like if you had x plus 1 equals 5, the solution to that equation is x equals 4, because 4 plus 1, because you can replace x with 4. And it makes it true. 5 equals 5. Check. Okay, but so anyway, here are the 3 special cases. If you had something like 5x is equal to 0, or negative 5x is equal to 0. One thing to keep in mind is whenever you're solving for a variable and you have 2 numbers multiplied together, and by viewing this as x is a number, 5 times something is equal to 0. Well, if 5x were 10, you'd divide by 5 and get x is 2. If 5x equals 15, you'd divide by 5 and get x is 3. Well, what multiplied by 5 gives you 0? Well, the only possible number you can multiply 5 by to get to 0 is just 0. So keep that in mind. I mean, it's not any big deal. It's just that sometimes our eyes don't see that as well, and we need to adjust our eyes and our brains to work together so that we're understanding that 5 times a number equals 0. Well, anytime you multiply 2 numbers together and get 0, one of those numbers, at least one of those numbers, has to be 0. So keep that in mind. All right, second case. Second case is when you have something like 3x plus 1 is equal to 3x plus 2. Well, sometimes we get equations like this after we've simplified both sides. And remember, the next step was to pick sides. Well, if you notice, if we subtract 3x from both sides, we're not going to have any more x terms. Well, that's right. And so that's what we want to do. We want to subtract 3x from both sides, and we end up getting 1 is equal to 2. We get a statement that's never true. Okay? So 1 can never equal 2. Now think about what this means. It means that no matter what you replace x with, it's always going to come out to a statement that's never true. You can't figure out an x. You can't put one value for x here and a different value here. Whatever you put here, you've got to put right there. So therefore, if let's say it's 5. If you put a 5 there, 3 times 5 is 15. 15 plus 1 is 16, equals 15 plus 2 is 17. So no matter what you put in there, it's never going to be the same. You're never going to have the left side equaling the right side. And if you get a statement that's never true, and then you would conclude that those 3 dots mean therefore. Therefore, we would conclude that there is no solution to this equation. No way can you solve the equation because it's never going to be true. And remember, when we solve an equation, we're trying to find all the real numbers that make it true. So if we can't find any real numbers that make it true, then there are no real numbers that make it true, no solution. All right, finally, if we take that same example, let's actually take 3 plus 2x and set that equal to 2x plus 3. Okay, well, I mean, if we rewrote this in standard form with the x term first, 2x plus 3 equals 2x plus 3. Well, we have a statement that's always true. And to show that it's always going to be true, you can subtract 2x from both sides. This is the algebraic way of showing that it's always true. And those terms cancel each other out, and we get a statement, 3 equals 3. Well, 3 is always equal to 3. So the statement, regardless of what you replace x with, you're always going to get a statement that's true. And if you get a statement that's always true, we call that an identity. Okay, so we call that an identity. And you can also say that the solution is all real numbers, all real numbers. And there's a kind of a cool symbol for all real numbers. And all real numbers looks like this. Like it's 2 vertical lines, and then the R, capital R, starts there. Okay, and I just want to be clear. That's not an IR. It's 2 vertical lines with the kind of top left part of the curve part of the R is right there. So I'm being very specific because I've seen too many times students say IR. It doesn't make any sense. So all real numbers is the solution there. So the homework assignment is posted, and please go ahead and get started on that.